Hey there, future EMPs. Professor Ortiz here. As we wind down towards the end of the semester, we're going to expedite certain things. We're going to be posting the cleaning and corrosion lecture and the weight and balance this weekend. So please make sure that you stay on top of things. Again, there are several of you who are falling behind. I don't want to single anyone out. I did send out messages. Please keep an eye out for my messages to you through your Canvas. That's the way I communicate with you. Also, I got some messages inquiring what's going to be on the next exam. I'm going to say this. You are a college student, okay? So, in order for you to succeed in college, you have to read. So, that's why we put out the syllabus. When you have the syllabus, you can go week by week and it'll tell you exactly what's going on that week. So, those of you who are asking me what's going to be on the exam, obviously you're not reading the syllabus. It takes time for us to develop the syllabus. That is the roadmap of the semester. So, when students are asking me what's going to be on the exam, it's very clear that you're not reading the syllabus. Everything is on the syllabus. If you have a question about what's going to be on the exam, read the syllabus. That's why we created it. You can refer and default back to the syllabus. And if you have any questions after that, you can reach out to me. I have no problem guiding you. I have no problem instructing you. However, as a college student, you need to do your due diligence, right? You have responsibilities such as reading. How about you read the syllabus? That would be a good start. If you want to be successful in college, you should start reading. So I know the majority of you do read the syllabus because the majority of you are not reaching out to me asking me what's going to be on the exam. 95% of you already know because you're reading the syllabus. Okay? So it doesn't make any sense to me why people are asking me what's going to be on the exam when it's on the syllabus. Anyhow, I am here to support you. I am here to make sure that you succeed. However, you need to put your part. Okay, we can't do everything for you, and you know if I'm talking to you, if you are that person that has not read the syllabus. Anyhow, shifting gears. All right, future AMPs. With that house cleaning behind, let's get started. So it's a good segue for us to get into cleaning and corrosion in aviation. Today's lecture is going to be pretty lengthy, but I'll try to make it as quick as possible and not hold you up here too long. I will be posting all the slides, the lecture today, and supporting materials. You know, we spend a lot of time and effort creating all this material for you, and there is a way for Canvas to report who is actually logging in, who is actually opening the different modules, who actually watches the video. So as instructors, we're able to know who's engaged, who's doing their work. And if you're logging in to Canvas every other week, you're probably not going to make it. I'll tell you that much. So, starting with with the lecture, let's move forward. When we talk about cleaning and corrosion, it is the inevitable result when metals are exposed to water and air. Since all aircraft contain some metal, they require constant inspection and cleaning to minimize the destructive effects of corrosion. Dirt and grease are the visually unappealing and can hide corrosion and structural damage. I think some of you have walked some of the parts that are there in the lab, the parts that have a lot of grease buildup. You can actually not tell if there's corrosion. So we have to remove all that grease, all that dirt of years and years of collection before we can actually inspect. for corrosion. And then furthermore, dirt can trap moisture and corrosive metals and materials next to the aircraft structures, hastening the formation of corrosion. Therefore, you must be aware of proper cleaning procedures that remove buildup, contaminations without damaging the materials used in structural components. In addition, you must learn appropriate methods of corrosion control to minimize corrosion's effects once it has become established. Now, while a clean aircraft is more visually appealing than a dirty one, appearance is a secondary consideration in aircraft cleaning. So, that is all to say that we clean aircraft not to make them look beautiful, although customers like a clean, beautiful plane. But as AMPs, we clean them so we can visually inspect for corrosions or any destructive measures or stress fractures that the aircraft has endured or survived. When we look at Appendix Delta of the FAR, Part 43 requires that airframe and engine be cleaned before performing an annual or 100-hour inspection. In addition, common sense and good maintenance practice require that an aircraft be kept clean. Dirt can cover up crack and damages components, as well as trap moisture and solvents that lead to corrosion. If allowed to accumulate over time, dirt and debris can build up to a considerable weight and decrease the useful load of the aircraft. Therefore, the cleaning of the aircraft exterior and interior should not be taken lightly. The materials and procedures presented in this section are intended as guidelines only. You should always follow the manufacturer's recommendation for cleaners, solvents, and cleaning procedures. Now, when we talk about weight is one of the biggest enemies of flight, right? Because the more weight you are transporting or carrying, the harder the engines have to work. So when you have buildup of dirt and grease all over the aircraft, that starts adding pounds to the weight of the aircraft, which means that you will be able to carry less. And in aviation, that is precious. Exterior cleaning. The first and most important step in corrosion control is to keep the exterior of an aircraft thoroughly clean. However, before you start washing an aircraft, there are certain areas and components that must be protected from cleaners and water sprays. A good example would be the pitot tube or static openings should always be plugged or taped prior to cleaning an aircraft to be prevented with the water ingestion of either the pitot tube or any other component that can be damaged by water or solvents. And then furthermore, wheel and brake assemblies should be covered to keep out cleaning agents. Although not readily apparent, it is extremely important that it recommended by the aircraft manufacturer or the mil spec approved for a particular application. The use of non-approved or ordinary commercial compounds or chemicals can result in the condition known as hydrogen embrittlement. Hydrogen embrittlement results from chemical reactions procedures hydrogen gas that is absorbed into the metal and destroying the metal and its integrity. Now also, the engine cowling and wheel well are usually full of grease and oil deposits that require special treatment and observation. So those are the one areas where you need to really be careful, okay? Because as the landing gears go up and down, there's hydraulic fluid, there's all kinds of stuff, there's debris, there's grass, there's dirt, there's all kinds of stuff being built up on the landing gear. And typically, these areas must be soaked with a 1-to-2 mixture. That's the ratio of emulsion, cleaner, and water. After allowing the cleaner to remain on the surface for a few minutes, scrub the heavily soiled area with a soft bristle brush to completely loosen the dirt, and rinse it with a high-pressure stream of water. Now, when we talk about the type of materials to be used in cleaning, depends on the nature of the element that need to be removed. For example, Removing a grease or oil or soft preservative compounds, dry cleaning solvents, naphtha is often used. The most two common types of naphtha are aliphatic naphtha and aromatic naphtha. Aliphatic naphtha is the hydrocarbon solvent that dissolves oil and grease but does not harm rubber or acrylic components. That is huge, right? Because if you're applying chemicals that's going to destroy plastic or rubber, you might damage certain areas, certain lines, certain hydraulic fluid lines, right? And the aromatic naphtha, on the other hand, attacks rubber or acrylic compounds or materials. Because it is safe on most materials, aliphatic naphtha is frequently used to wipe down clean surfaces before painting. Chemical cleaners must be used with great care in cleaning assembled aircraft. The danger of entrapping a potential corrosive solvent is faying surfaces and crevices counteracts any advantages in their speed or effectiveness. For example, caustic cleaner can cause corrosion on aluminum or magnesium alloys and therefore should not be used. Magnesium engine parts should be washed with a commercial solvent and decarbonized and then scraped or grit blasted. Before they are painted, magnesium engines parts should be wiped down with a dichromate solution to improve paint adhesion. When cleaning aluminum, you should always use cleaners which are relatively neutral and easy to remove. If you must use an abrasive or remove corrosive or corrosion products for aluminum structures, use aluminum wool or aluminum oxide sandpaper. Now, let's look at when using chemical cleaning agents. First and foremost, open all circuit breakers associated with battery power prior to applications of flammable solvent because you're going to be powering down the aircraft. If you can't get into a compartment and it's actually electrically operated, the door or the compartment, then you won't be able to open it once you completely shut down the power or disconnect the battery, in other words. Now, do not use synthetic wiping cloths with flammable agents. Wiping cloth made of natural materials such as cotton should be used. Be careful with alcohol. Now, I've seen some mechanics even use jet fuel sometimes to wipe down certain difficult areas. Now, although jet fuel can really break down dirt and really help you expedite the cleaning process, it's also very flammable. So you don't want to use any type of avgas or any type of jet fuel or fuel at all. Do not use synthetic wiping cloths, right? Chemical agents should not be applied with atomizing spray equipment. This is not only hazardous, but violates environmental regulations in most areas. Now, remember, as an A&P, you might be traveling in to different countries, to different states, to different parts of the world, that rules and standards might be different. So you have to be familiar with local policies, standards, and laws. Keep all agents away from open flames, any live electrical circuits, or potential sources of electrical arcing. Very important. Also ensure that residual agents are removed from the aircraft, engine bays, and equipment. Do not mix any cleaning agent with any solvent. Do not use cleaning compounds at higher concentrations that is recommended. Do not allow cleaning agents to dry on aircraft surfaces. You got to wipe them down quickly. Such practices can cause streaking and damage to aircraft finishes and components. To prevent entrapment of water and cleaning agents inside an aircraft part in structural areas, all drain holes, flap valves, etc. should be open before washing to ensure the proper drainage occurs, and you're not holding water in certain areas, which can really create corrosion. When using ammonium hydroxide, do not breathe vapors, avoid skin contact, wash immediately if such contact occurs. Do not use excessive amounts of cleaning agents on control cables. The agents can remove internal lubricant. To avoid excessive amounts of agents, wipe cable with a clean cloth, dampen with the agent. So you spray on the cloth and then you use the cloth. Do not spray directly onto the part and then you're gonna go and wipe. Okay, so here's your clean cloth. You spray it on the cloth and then you get the cloth and then you wipe the part. All right, now when high strength steels use some strength aluminum and some stainless steel are exposed to acid paint removers, planning solutions or other acidic condition, cleaners, etc., or even some alkaline agents. So some of this stuff can really damage the aircraft. You have to be able to read what the chemical agent is used for. Now, if the part is under load or constrained residual manufacturing stress, sudden catastrophic failure can occur and the part may no longer sustain internal and or applied stresses. Hydrogen embrittlement has been known to occur in parts stressed to only 15% of the nominal tensile strength. Now, when using high pressure water spray, you must exercise caution. For those around you, you're using spray, right? This is especially true around the engine components. For example, if high pressure water is used to degrease an engine, you must avoid spraying electrical components such as the magnetos and wiring harnesses. Furthermore, high pressure water sprays can rinse the lubricant from bearings and grease fittings. Therefore, after washing wheel wells, flat tracks, and hinges, you should lubricate them to force out any water to prevent corrosion. All right. So also, when you are using a high pressure spray, you might want to also be careful with the other aircrafts that are around you, because that spray, especially if they're not inside the hangar, if there's a breeze, that water can travel to the next aircraft. So you have to be very careful. Now, exterior finish maintenance. A clean, polished surface denies corrosion a place to start. Therefore, aircraft should be kept clean and waxed. All drain openings must be kept open, and deposits which have formed from engine exhaust must be removed before they build up excessively. Avoid damage to an aircraft by not using harmful cleaning, polishing, brightening, or paint removing materials. Use only those compounds which conform to the existing government and established industry specifications, or products that have been specially recommended for the aircraft or by the aircraft manufacturer as being satisfactory for the intent of the application. Observe the product's manufacturer's recommendation concerning the use of their agents. Again, please read. You're a college student. Please read. Now, when it comes to non-metal cleaning, the non-metallic aircraft components sometimes require different cleaning techniques than metal. For example, the slightest amount of dust on a plastic or plexiglass surface can scratch the finish if rubbed with the dry cloth. Furthermore, the use of dry cloths also builds up a static charge on the window that attracts more dust. Therefore, before washing a plastic window, rinse the area with water first. Once clean, dry the window with soft cloth. So, rinse it with water first, then you clean it, then you got to go with the dry cloth and remove everything, okay? Oil and hydraulic fluid attack rapidly destroy the rubber in aircraft tires. Therefore, whenever these fluids are spilled on a tire, they should be immediately wiped off with a dry towel. The tires should be washed with soap and water. Because most cleaning solvents are petroleum based, soap and water are the only approved solutions for cleaning tires. Soap and water. Okay, soap and water. That's your best friend right there. So rubber dice boots have a conductive coating to help dissipate static charges. Therefore, some composite structures such as Radomes are painted with special materials that are transparent to radio signals or waves. These areas should be cleaned gently and never subjected to abrasive or stiff brushes. If you have a question as to what type of cleaning solution to use, consult the manufacturer's specification. Always default or refer back to the manufacturer's specifications. They are the ones that will be able to provide you with the information that you need. Power plant cleaning. So accumulated dirt on power plants can cover defects and lead to overheating. So the dirt and debris can cover something that's damaged. You will not be able to notice it if you simply just do a visual inspection. For this type of inspection, you actually have to clean areas so you can see. And therefore, aircraft engines should be cleaned on a regular basis. However, when doing this, all electrical components in the engine compartment must be protected by solvent and or soaps, right? So solvents or soaps can really destroy electrical wiring, electrical harnesses, any electrical components. So be very mindful of that. And this includes wrapping the magnetos so no water can get in the vents. If the power plant is located over the landing gear, the gear's brake and tire assemblies should be covered in plastic as well. If you use a high pressure water spray, avoid spraying the starter, alternator, and air intakes with solvent or water rinse, because they will actually make their way into the power plant and destroy the internal components or integrity of the aircraft. Prior to washing an engine, inspect it for excessive oil leaks, right? That is going to happen. Then apply a soap or solvent solution to the engine and allow it to set for several minutes. Heavy accumulations of dirt and grease can be scrubbed with a bristle brush to loosen them. The engine is then rinsed and allowed to dry. If volatile solvent was used, be sure to make sure that you give it enough time to dry before starting the engine to minimize the risk of fire, right? Remember I said some of these chemicals are flammable. Lubricate all controls and rod ends in the engine compartment to remove protective covers that are installed on electrical components. Now, shifting gears, corrosion and its control are a primary importance to all A&Ps and aircraft owners. Corrosion weakens primary structural members, which must then be replaced or reinforced in order to sustain flight loads. Flight creates stress, structural stress. Such replacements of reinforcements are costly, so a lot of money goes into this. Time consuming and result in unscheduled delays. Now, delays means money, especially for the aircraft owner or the company. Most metals exist in nature as chemical compounds such as oxides or chlorides. For example, aluminum is never found in nature in its pure state, but most be refined from an ore such as alumina. However, when pure aluminum is exposed to these elements, it combines oxygen and eventually changes back into alumina. Corrosion then is simply a process wherein metals return to their natural state. Corrosion is a natural phenomenon which attacks metal by chemical or electrical chemical action and converts it into metallic compounds such as an oxide, hydroxide, or sulfate. Substances that cause corrosion are called corrosive agents. Water or water vapors contain salt combined with oxygen in the atmosphere to produce the most prominent corrosive agents. Additional corrosive agents include acids, alkalis, and salts. The appearance of corrosion varies with various metals. For example, on aluminum alloys and magnesium, it appears as surface pitting and etching, often combined with a gray or white powdery deposit. However, on copper or copper alloys, corrosion forms as greenish film. On steel, a reddish rust. When corrosion deposits are removed, the metal surface may appear etched or pitted depending upon the length and severity of the attack. If deep enough, These pits may become sites for cracks that can develop into bigger structural issues or problems. Some types of corrosions can travel beneath surface coatings and can spread until the part fails. Another way that you can tell is you can look at the paint, because if there's corrosion under the paint, it will look slightly different than the rest of the undamaged or not corroded area. There will be bumps, bubbles, pitting. That's the way that you're able to identify corrosion under paint. And the paint might still be good. Now, when we talk about chemical corrosion, pure chemical corrosion results from the direct exposure of a bare surface to caustic liquid or gaseous agents. The most common agents causing direct chemical corrosion include spilled battery acid or fumes from batteries, residual flux deposit resulting from inadequate cleaning, welded, brazed, or soldered joints, and trapped caustic cleaning solutions. Electrical chemical corrosion is similar to electrical reaction that takes place in the dry cell battery. To understand how this happens, you can recall the structure of the atom when we talked about in a couple of weeks ago. When the number of electrons matches the number of protons in the atom is said to be electrically balanced. However, if there are more or fewer electrons than protons, the atom is said to be charged and is called an ion. If there are more electrons than protons, it is a negative ion. But if there are more protons than electrons, it is a positive ion. So now let's talk about types of corrosion. Corrosion is a very general term and may appear in a variety of forms, depending on the metal involved and the corrosion producing agent present. As an A&P technician, you must be familiar with the different types of corrosion as well as how to identify them. In this lecture, we'll review some of those. Now, oxidation. One of the simpler forms of corrosion is dry corrosion, or as it is commonly generally known, oxidation. When a metal such as aluminum is exposed to a gas containing oxygen, a chemical reaction takes place on the surface between the metal and the gas. Two aluminum atoms join three oxygen atoms to form aluminum oxide. If the metal is iron or steel, two atoms of iron join three atoms of oxygen to form iron oxide or rust. There is one big difference between iron oxide and aluminum oxide. The film of aluminum oxide is unbroken, and therefore, once it has formed, further reaction with oxygen slows dramatically. Iron oxide, on the other hand, forms a porous, interrupted film. Since the film is not airtight, the metal continues to react with the oxygen in the air until the metal is completely eaten away. Now, down below, you can see the corrosion on this metal. Now, in this area, in this slide, we can see the water droplet here, right? Here we have the air component. Now, rust starts to develop here. Notice the color, right? And this here is the surface of the part. So, air and water droplets combined start to build up this corrosion. I hope that makes sense. And this is with an iron material or surface. Uniform surface corrosion. Where our area's unprotected metal is exposed to an atmosphere containing battery fumes, exhaust gases, or industrial contaminants, a uniform attack over the entire surface occurs. This dulling of the surface is caused by microscopic amounts of the metal being converted into corrosion salts. If these deposits are not removed and the surface protected against further action, the surface becomes so rough that corrosion pits form. Corrosion sometimes spread under the surface and cannot be recognized by either roughening or surface of powdery deposits. Instead, the paint or plating lifts off the surface in small blisters due to the pressure of the underlying accumulation of corrosion of the products or materials or parts. Now, remember I told you, paint can hide corrosion, but you can visually see and you can run your finger, if in doubt, and you'll start feeling the bubbles. You can start feeling the rust under the paint. Some of the paint is so strong and so durable that it'll hide the corrosion. So you have to be very careful. A common type of uniform surface corrosion is caused by the reaction of metallic surface with atmospheric contaminants. These includes airborne, chlorine or sulfur compounds, oxygen, or moisture in the atmosphere, reactive compounds from exhaust gases, as well as fumes from storage batteries frequently cause uniform surface corrosion. The amount of damage caused by uniform surface corrosion is ordinarily determined by comparing the thickness of the corroded metal with that of an undamaged specimen. So you take them side by side and you'll see the thickness of the damaged metal and the thickness of the undamaged metal, and then you will be able to gauge the difference, how much damage is really there. Now, pitting corrosion is likely a result of uniform surface corrosion left untreated. Pits form as localized anodic areas, and corrosive actions continues until an appreciable percentage of the metal thickness is converted into salts. In extreme cases, these can eat completely through the metal. Pitting corrosion is usually detected by the appearance of clumps of white powder or powdery surface areas. Now, when we talk about galvanic corrosion, this is a very common type of corrosion which occurs anytime two dissimilar metals make electrical contact in the presence of the electrolyte. For example, galvanic corrosion can take place where dissimilar metal skins are riveted together, or where aluminum inspection plates are placed to the structure with steel screws. This is a good example down here, right? So this is metal screws, and down here is the aluminum. And because they're making contact right here, all around, and then probably water touched the area, right? And then the water kind of drops in here, makes its way in through the channels of the screw. The water makes its way all the way down and starts kind of spilling to the sides, and that's where we start developing that corrosion. Same on this side. Concentration cell corrosion, or crevice corrosion, is corrosion of a metal in a metal-to-metal joint. Corrosion at the edge of a joint even though the metals are identical, or corrosion of a spot on the metal's surface converted or covered by foreign materials. Now, if there is an area where water can accumulate, right, where it will start creating more and more corrosion, okay, and then it'll start elongating and creating more and more damage. Now, if you continue to fly, this weak part will start to disintegrate. And when you land, let's just say you land in Seattle where it's super rainy. Now, this just became a bigger hole. More water will start getting in there. And then they fly to another rainy area, and more, and so on. And through the years and through time, the corrosion will start really damaging the aircraft. Now, oxygen concentration cell corrosion. When water covers the surface of an aluminum aircraft skin and seeps into the cracks between lap joints, oxygen concentration cell corrosions can form. Since water in an open area readily absorbs oxygen from the air, it also attracts electrons from the metal to form negative hydroxide ions. The electrons required to form these negative ions come from the metal itself. The area between the skins does not give up electrons to the water on its surface because there is not enough oxygen there to have hydroxide ions. Instead, its electrons flow to the cathodic surface, the open area. The area between the skins, having lost electrons, now contains positive aluminum ions, and this area becomes an anode, which is corrosive. Metal ion concentration cells are very, very common in aviation. You have to be very careful. You have to be aware. First, you got to know what you're looking for. Just like when I'm talking about when students are asking me what's going to be on the exam, how about you read the syllabus, right? So when you're wondering, like, hey, what type of corrosion is this? Instead of going all around the shop, do a little bit of research, especially in the beginning of your career, right? Do some legwork. And then you, by doing research, you'll become more and more knowledgeable. Now, filiform corrosion is a special form of oxygen concentration cell corrosion or crevice corrosion which occurs on metal surfaces having an organic coating system. It is recognized by its fine, thread-like lines under polyurethane enamel finish. Filiform corrosion often results when the wash primer used on a metal has not been properly cured. A wash primer is a two-part metal penetration material in which phosphoric acid converts the surface of the metal into the phosphate film that protects the metal form. Intergranular corrosion is an attack along the grain boundaries of a material. Micro photographs of the aluminum alloys show that they are comprised of extremely tiny grains held together by chemical bonds. Each grain has a clearly defined boundary which form a chemical point of view, differs from the metal within the grain center. The grain boundary and grain center can react with each other as an anode and a cathode when it contains or contacts with electrolyte. Stress corrosion occurs when the metal is subjected to a tensile strength in the presence of corrosive environments. The stress in the metal can come from improper quenching after heat treatment or from the interference fit of a fastener. Stress corrosion can be transgranular or intergranular in nature. Cracks caused by stress corrosion grow rapidly as the corrosive attack concentrates at the end of the crack rather than along its side. Fretting corrosion occurs when two surfaces fit tightly together but can move relatively to one another. Corrosion occurs. This type of corrosion is the result of an abrasive wear caused by the two surfaces rubbing against each other. This rubbing, known as fettering, prevents the formation of protective oxide film, exposing the active metal to the atmosphere. By the time this type of corrosion makes its appearance on the surface, the damage is usually done and the parts must be replaced. Corrosive agents are substances that are capable of causing a corrosive reaction. Most corrosive agents fall into one of two categories: acids and alkalis. However, care must be taken not to overlook other obvious corrosive agents such as the atmosphere, which contains moisture, salts, and corrosive industrial agents. Ferrous metals are subject to damage from both acids and alkalis, but aluminum is more vulnerable to strong alkaline solutions than it is to acids. For example, an aluminum structure can severely be corroded if it is allowed to remain in contact with a concrete floor. Water draws out enough lime from the cement to form an alkaline solution that corrodes the aluminum. So leaving parts on the ground is not a good idea. Now we're going to shift gears a little bit. Mercury, although it is not commonly found in any quantity around aircraft, there is a definite possibility that mercury could be spilled in an aircraft. Hazardous cargoes are often carried in aircraft. The damage from a shifting load can result in a damaged container and hazardous spill. So it's transport, logistics, right? A lot of folks in this A&P program will be working for UPS or FedEx, which might fall into a division where you're transporting industrial chemicals or parts which might contain mercury. Okay, now pure water reacts with metals to form corrosion or oxidation, but water holding a concentration of salts or other contaminants causes much more rapid corrosion. Seaplanes are in continual battle with the elements, and every precaution must be taken to stay ahead of the corrosion formation. Some of you might end up in Alaska, right? In Alaska, there is a lot of seaplanes which can be operating in salt waters, and those are especially vulnerable to attacks. And when one is taken out of the salt water, it should be hosed down with large volumes of fresh water to get every trace of salt off the structure. Seaplane ramps are often located in areas where there is concentration of industrial waste, making the water even more corrosive. Detection methods, right? So we got to be able to identify things. So to aid in the detection of corrosion, you should use every inspection aid that is available to you. A good example would be the complex structure of modern aircraft makes the use of magnifying glasses, mirrors, borescope, fiber optics, and other optical inspection tools imperative for a good visual inspection. Stress corrosion cracks are often sometimes difficult, if not impossible, to detect by the visual inspection alone. However, as discussed previously in some of our lectures, any fault that is open to the surface may be found through the dye penetrant inspection. The main limitation of dye penetrant inspection is the fact that it can fail to find cracks that are so full of corrosion products that the dye cannot penetrate. Also, penetrant cannot get in the crack that is filled with oil or grease. Porous or rough surfaces are almost impossible to clean of all penetrants, so materials with rough surfaces do not lend themselves to this type of inspection. Corrosion-prone areas. Modern airplanes or aircraft are made of thin, reactive metals with a tolerate very little loss of strength. Therefore, one of the most important functions of an A&P is to check the entire aircraft for indications of corrosions which could damage or disintegrate the integrity or strength of the structure. Almost all parts of an airplane are subject to this type of damage, and you should be inspecting them. But certain areas are more prone than others. Now, when we talk about engine exhaust area, reciprocating engines or turbine engines generate power by converting chemical energy from hydrocarbon fuel into heat energy. Because of the inefficiency of the engine, much of the heat along with the energy-rich gases pass out through the engine through the exhaust. These gases contain all of the constituents for a potent electrolyte, and because of their relative elevated temperature, corrosion forms extremely rapidly. Battery compartments and vents. Batteries stored electrical energy by converting it into chemical energy and are therefore actively chemical plants, complete with environmental pollutants that go through the exhaust. Airplanes having lead acid batteries must have their boxes protected by a material that resists corrosion from the sulfuric acid fumes, and airplanes with nickel cadmium batteries must have their batteries areas protected by an alkaline resistant finish. These finishes can have a lot of destructive agents that can really destroy the integrity of the battery. During an inspection, you will be tasked with looking at and inspecting the areas around the batteries, which must be fully checked, especially under the battery. Okay, that's key. And all traces of corrosion must be removed and the area refinished. Therefore, you should verify that the battery has a sump vent jar containing an absorbent pad moist with a neutralizing agent. Lead acid batteries require caustic soda, boric acid can be used in nickel cadmium batteries. These sumps vent jars should be checked all the time for their integrity and make sure that there's no leakage. The toilets and food services. Organic materials such as food and human waste are highly corrosive to aluminum surfaces. Look, sooner or later you're going to know about blue juice. Blue juice is toilet water. Stay away from it. If you see blue juice, blue water, don't touch it. And also, moving on with our lecture, therefore, areas in proximity to these materials, such as the toilets and food services areas, must be inspected with extreme care and caution. Food service areas can be troublesome if there is a possibility of food debris getting to cracks under or behind the gallery where it cannot be removed or seen by the naked eye. While this material in itself may not be corrosive, it can hold water, which can trap air and water and produce corrosion. Now, engine mounts. When a reciprocating aircraft engine is started, the heavy current from the starter must return to the battery through the engine mount. This current flows through the joints in the mount and creates the potential difference required for corrosion to form in these areas. So to protect welded steel tubes mounts from the internal corrosion, the tubing should be periodically filled with hot linseed oil or other type of tubing oil. The oil is then drained and the drain hole plugged with the drive screw or self-tapping metal screw. Now, when we talk about corrosion removal, and this is the last part of this lecture, is previously discussed, the first step in corrosion control must be cleaning the surface, making sure it's super clean. After the surface is completely clean and it is determined that the corrosion does not exist, the damage must be carefully assessed and a decision must be made as to what the action should be taken. Also gauging the extent of the damage the corrosion created, if any at all. So all corrosion products must be removed as soon as they are discovered or identified, because corrosion continues as long as the deposit remains on the surface. So corrosion under a paint film cannot be thoroughly inspected without first removing all the paint. However, before using an unfamiliar paint remover, first test it on a piece of metal similar to that on the aircraft. One thing to keep in mind is never use caustic paint remover. In other words, like paint thinner. Be careful. Prior to applying a paint remover, all areas not be stripped should be masked with heavy aluminum foil. This keeps the stripper from accidentally coming into contact with these areas. So there's a big roll of tape that you'll see once you get to your duty station. That big roll of, it's like foil, it's a foil tape. You can use that. However, that thing is super expensive. Okay, be mindful of that, because if your boss sees you using it without caution or without regard to the cost of that, they're gonna address that issue, because I think that roll of tape is like $400 for the little roll of tape. So be careful. Don't be that guy that's using it for their own personal reasons. I've seen guys take some of those rolls of tape home, and that guy had a party and invited pretty much all the crew from our hangar. And when we were in their garage, my boss saw rolls and rolls of tape that he had brought home, and that person got fired. So don't be that guy. Now, water rinsable paint remover having a syrupy consistency is usually best for aircraft surfaces. This type of remover is applied with a brush by just gently like dabbing onto the area where you really want to inspect. This breaks the bond between the finish and the metal, and then it'll reveal itself so you can inspect the area. It also might be necessary to reapply the remover. If so, scrape the old paint away from a plastic or aluminum scraper and apply the second coat of remover. This allows the active chemicals to get to the lower layers of the finish. So here is an example, right? This person has masked the area. See that? This is that aluminum tape that we're talking about. Okay, so if any of the solvent wants to kind of leak out, it'll stop right there. And you'll be able to like control. Now, I think these are rivet holes. I hope these are rivets. But if these are holes, I would also run foil tape here. Now, if they are rivets indeed, then you don't really have to worry about that. But the solvent can't make its way here if these are actual holes that are not plugged. So be mindful. And what can happen is if you don't use this tape, some of this solvent can spill over and it'll go right off the side of the tip of the wing, land here, and it'll eat the plastic from this light. And it'll make its way in there, and there is electrical components in there. So, get my drift? I hope you do. Treatment of aluminum alloys. In general, corrosion of aluminum alloys can be more effectively treated on the aircraft than corrosion occurring on the other structural materials. Treatment includes the mechanical removal of such or much of the corrosion as practical, and the neutralization of residual materials by chemical means, and finally, the restoration of the permanent surface coating. Now, we're coming to the end of this week's lecture, and I just have two more slides, I think. But I want you to know that I encourage you to go through this and supplement with your own reading of this area and section. Okay, so the lecture is a supplement of your reading. I hope that everyone is reading each chapter. I talked about this before, is when you go to the store, to a supermarket, and you hand over your money, do you walk out of there with nothing in your hands? No. You hand over your money to the cashier and you want to walk away with something. You should have that same mentality and same philosophy when it comes to school. You're handing over money. Some of you get financial aid, so it's taxpayers' money, right? But you should walk away with something. School is not free. Somebody's paying for it. So be mindful of that. Take something with you out of these classes. And I hope that you're studying for your FAA exam, because if you're not, and you're like, I'm looking forward to the summer, I'm just gonna chill, you're not doing what you're supposed to do. You can have these certificates, hang them on your wall, all you want, all over your office, all over whatever, social media. They're no good. All they're good for is to hang on the wall. What really matters is that you have your A&P license. That's what's going to get you the money that you're looking for. Okay, so you should be studying. You should be reading. And it's sad that I'm getting questions about what's going to be on the exam when we provided a syllabus for you and you're a college student. Now, Second to last slide. Pure aluminum is considered to be non-corrosive. However, this is not altogether true because aluminum readily combines with oxygen to form an oxide film. This film is so dense that it excludes air from the metal surface, thereby preventing additional corrosion from forming. The disadvantage of the using of pure aluminum is that it is not strong enough for aircraft structural components and therefore must be alloyed with other metals. Sealer and sealants. The higher speeds of modern aircraft have brought requirements for aerodynamic sealers used to fair the edge of wing skins. Airplanes flying in high altitudes require pressurized cabins, and as consequence, every place that plumbing or electrical wiring passes through a bulkhead must be sealed with some form of plastic sealer. Integral fuel tanks are actually a part of the wing structure, and every rivet joint must be sealed to prevent fuel leakage. That last sentence refers to the fuel tank. A lot of aircrafts that you'll be working with, their fuel tanks are actually the wings. So when you don't properly seal the wing, you might have a fuel leak, which is very, very dangerous. All right. Thank you, everybody, for taking the time to watch this video and this week's lecture. I appreciate you all. Keep up the good work. 99% of you are doing amazing. It's just that 1% that I'm worried about. I know everybody else, except for that 1%, everybody else is doing the readings, reading the syllabus, reviewing the materials, reading every week, preparing, doing the ASA, prepware. Your goal should be to take your exam at the end of May so you can just knock it out. Okay? If you have any questions, please feel free to reach out. I appreciate you all. Have a great rest of your day. Take care.